system, vehicles communicate using a technique similar to Wi-Fi, so that they can drive and regulate their speed cooperatively. Current high-end cars are sometimes equipped with a system called Adaptive Cruise Control, or ACC. ACC uses a radar to measure the distance to the preceding vehicle, called the headway, and tries to keep this headway constant. The ACC has some difficulties doing this, since its radar is slow to detect if a preceding vehicle is accelerating or braking. Connect and Drive enhances ACC by letting vehicles communicate via Wi-Fi. 10 times per second, vehicles broadcast their current position, their speed, and their acceleration and deceleration. With this information, other vehicles can regulate their speed much faster and much more precise, thus keeping the distance to the preceding vehicle constant. We call this Cooperative Adaptive Cruise Control, or CACC.
The contribution of the DAX Group from the University of Twente is the following. First, for the merging procedures that you have seen here, we developed the control algorithms, and also for the merging procedure we developed the geocasting algorithm, so the mechanisms that distribute the packets between the cars. And the idea is that there is a roadside unit, like over here, and the cars approaching the merging area get messages in multiple hops, and we control how these packets are distributed between the cars. And then the third contribution of our group is in the beaconing, and especially the definition of all the packet formats. But also, if we look at a system like here, we have only 7 cars, so there is no issue with load of the network. Plenty of space. But later on, if we have like 100 cars, there might be issues with load. And you can see here, for instance, that if you would have 100 cars at 10 Hz beaconing rate, then only 10% of the packets get through. And we make adaptations to the network to deal with that kind of problems.